Algebra 1, 5.1.4, comparing quadratic functions. Okay, the first problem is about Maya. Maya saved up some money and decided to take a risk and invest in some stocks. She invested her money in Dougal, a popular computer company. Unfortunately, she lost it all in just 25 months. The change in her money during this time can be represented by the function v of x equals 75 plus 72x minus 3x squared, where v is the value of her investment and x is the time in months. There are three quadratic functions shown. Which of these models represents Maya's investment over time? And explain. So the first model is an equation, and the second model is a table, and the third model is a graph. So let's see what clues we can get out of this equation that we're given. We have an equation, and it's almost in standard form, but what we should do, and I've already done this, is rewrite it in proper order. So we'll put our negative 3x squared first, our 72x next, and our 75 last to get it in the proper order. And so if you go back to the question, you'll notice the negative 3x squared in the front means the parabola must open up. It would not open down. So model 3 opens up, so you should eliminate model 3 for that reason. Model 1 does open down. In model 2, if you'll notice, the numbers go up and then back down on your y's, so it will open down as well. So 1 and 2 are okay because they both open down. The next thing you'll notice is that we should start with $75, and that's because the y-intercept of this function, if you put a 0 in for x, you get a 75 out for y. This 75 at the end is where the graph crosses the y-axis. If you look at the model 2, this table starts at 0, 0. Well, that's on the y-axis, and it's not the correct y-intercept. So you should eliminate model 2 because it starts at 0, 0, and it really should start at 0, 75. And then you can choose model 1 because they do produce the same graph. So what I've done is I typed both equations into my Desmos, so you can put them here. Now you do have to go way out with your window. So my advice is to click on the wrench and make your Y maximum really big. I made mine 600. And if you do that, you should be able to see your parabola. And then if you'll click on one of your parabolas, make sure they're different colors, and then click on the other parabola like I'm doing here, it'll go back and forth and show you the colors are different, but the parabolas are the same parabola, and they both have all these same points. So it did start at 0, 75. It did stop at 25, 0. So the correct model for this problem was model 1. All right, let's move on to the next question. How much money did Maya initially invest? Well, we know that she invested $75. So let me put that. She invested $75. And the reason we know that is because the y-intercept was 75. So let's put that for our explanation. The y-intercept in your equation, and you can also see it in your graph. 3, the function that models Maya's investment over time has a maximum value. What was the greatest value of Maya's investment over time of her investment? So the greatest value would be the vertex, would be represented by this vertex. So if you've got your graph, click on your vertex. Your x is 12, and it looks like your y here will be 507, and that is dollars. So we're going to put $507, and we'll explain. This is the y coordinate of the vertex. So I'm going to highlight that in red. All right, how much time did it take for Maya's investment to reach its maximum value? All right, if you go back to your graph, the vertex was 12, 507, so that means in 12 months it reached a maximum of 507. So the amount of time here will be 12 months. So let me put this, 12 months. And what is this? This is the x coordinate of the vertex. I'll highlight that in red. Okay, the last question says, on average, how much did Maya's account gain in value each month from the time she opened the account till the time it reached its maximum value? All right, when it says on average, it's asking you for average rate of change. So let me back this up a little bit because I need some more space. And let's use the equation editor for this one. So let's change, I'm going to change it to red, and then I'm going to type a new equation, and we're going to do change in y over change in x. So there's actually a little triangle in here, delta y, and on the bottom we're going to put change in x. Alright, so to do change in y over change in x, which is the average rate of change, I need to figure out which two order pairs it needs to do this. So in your Desmos calculator, if you've already done this problem, you can highlight, highlight not -10, but 0.75, because that's when she started, and then highlight or click on 12,507, because that's its maximum. These are the two order pairs. I don't really need the 25 zeros, so I'm going to turn that off. So the change in y would be from 75 to 507. So I'm going to take and subtract those two numbers. So let's put new equation equals, and then we'll put a fraction in, just like before. And then we're going to put in change in y, so that will be 507 minus 75. Let's put that on top. 507 minus 75. And then change in x, the x coordinate was 12, and then 0. So this x coordinate at the top here was 12, and the x coordinate where you started was 0. So when you subtract those numbers, that's going to give you the change in x. So using your Desmos, you can do the math in there. It'll do it down here. Just click on the next row. Type 507 minus, what was that? That's the problem. You click over here, it makes these go away, but it's 507 minus 75. All right, and then it gives me the answer here, 432. So I'm going to put that on the top here. So let's put equals, and put another fraction, and put 432. All right, and then underneath there, we're going to put our 12. Now, go back to your Desmos calculator. You can use the same one again if you want. So I'm going to take 432 and divide it by 12. And at the bottom right, it shows me that that's 36. So the answer is 36. But you can't just say 36. 36 what? Well, it's $36 because she invested money over 12 months. So your answer will be $36 per month. So that is her average gain in value each month is $36 per month. Okay, in this next activity, you're going to compare two different quadratic functions. So last time we just looked at one function and found the correct representation to go with it. But this time these are going to be different functions altogether. Josiah compared the table of values for f of x and the graph of g of x to determine which quadratic function has the greater maximum value. Well, one nice thing about graphs is that you can really see the maximum value just by looking, particularly if they're labeled well. So you'll notice that the y-axis here is counting by, it's actually counting by ones, but they labeled every other tick mark. So if you look at this vertex, it's at the top of the parabola, and it does appear it's not at 13 and it's not at 12. It looks like it may be at 12.5. So if I had to say the function g of x has the greater, or has a maximum value of 12.5, I don't know if it's greater. We'll talk about that in a minute, but I do want to write that down. The maximum value for g of x, and when we say maximum value, we're talking about the y-coordinate only. So the maximum value for g of x is 12.5, or really close to that. I'm pretty sure it's exactly 12.5. So let's now look at the function f of x. Well, it looks like the maximum value is 12, but the problem is we don't really know if this keeps going up or does it come back down. How can we tell? Well, the calculator will also help us do this. We can create a table in our calculator and analyze the numbers. So go back to your Desmos calculator. Clear out all this. You don't need it. And let's click on the plus sign and create a table. And we'll just create this table. So on the x column, you want -1, 0, 1, 2, and 3. And in the y column, we'll just put the y values that were given. The f of x values are your y values. So 0, 4.5. And 8, 10.5. And then finally, what's the last one? 12. Okay, so let's put a 12. All right, so what I'm going to do is go into this next column. We'll just call this Y2. You can call it whatever you want. But what I need to do is subtract these numbers to see what's happening. I can tell it's increasing from 0 to 4.5, and it went up 4.5. So I'm just going to put 4.5 here. But from 4.5 to 8, it is not increasing 4.5. So let's take 8 and subtract 4.5, and you're getting 3.5. So let's put 3.5 here. And then let's do 10.5 minus 8, and that is 2.5. And I'm kind of noticing a pattern here. I bet the next one's 1.5. 12 minus 10.5, and sure enough, it's 1.5. So the question is, what would the next one be? So let's say this is 4. I don't know what that is yet, but I do know this one should be 0.5 if it follows the same pattern. 4, 3, 2, 1, 0.5. So if I'm going to add a 0.5 to the 12, I get 12.5. Ooh. Well, the other one was 12.5, so we might better do another one. So what are we going to do now? Let's see. I'm decreasing 1 each time. I went from 4.5 to 3.5 to 2.5 to 1.5 to 0.5. So I would have to go to -0.5 to go down 1. So if I subtract 0.5 from 12.5, I get 12. So let's go back and look now at the graph. It looks to me like these functions have the same maximum because the maximum for g appears to be the same as the maximum for x. So even though they said these were different functions, you know what? I don't think they are, because at 2 we had a 3, and at 2 we had a 12, at 3 we had a 12, and guess what? I think the same was true over here on our Desmos. Oh, no, 3 was 12, and 5 was 12. So they're not the same functions, but they do have the same y value, so that's interesting. All right, so the maximum value for g of x is 12.5, and the maximum value for f of x, that was the one in the table, is also 12.5, because we had the largest y value of 12.5 right here. See, it went back down again. Notice how we used differences to figure that out. We didn't use an equation. We didn't need to write an equation in the calculator. You can do that, but it wasn't necessary. So Josiah is not correct, because what did Josiah say? Josiah says the function g of x has a greater maximum. Well, Josiah is not correct, because the maximums are the same. They're both 12.5. So let me highlight that in red. And let's move on to our next question. Ben and Corrine are trying out their new drones, but they're not very good at flying them yet. The drones keep very precise records of their elevations. Compare these two drone flights launched at the same time. So the height of Corrine's drone flight over time in seconds can be approximated by this function. So since it's flight in seconds, height over seconds, the seconds is your x. So if you'll look at your equation, there's a couple of things we notice. It has that -3 in front, so that's telling us we have a parabola that opens down. It has a 1 at the end, so it's telling us the parabola starts at 0, 1. So it's going to go up and back down. Well, that's about all we know from that equation. So let's now look at the table. This equation starts, this table starts at 0, 4. So at 0 seconds, it looks like the height is 4 feet off the ground. So maybe Corinne was only holding her drone 1 foot off the ground, and it looks like Ben is holding the drone 4 feet off the ground. And so he releases the drone, and then it goes up and back down. So let's see what the questions are. Which flight began at a higher elevation? So looking at Corinne's flight, you'll notice the 1 at the end. This 1 is her starting height. And then again, we just said the 4, 0, 4 would be the starting height for Ben's drone. So the flight that began at the higher elevation, which is another way of saying the higher height, would be Ben's drone. So Ben's started at a higher elevation or height. 0, 4. And we need to say, how do we know? Well, because Corinne started at 0, 1. And we can tell because of the y-intercept at the end of her equation. She's got 2 N in her name, 2 N's in this name. Corinne started at 0, 1. Okay. All right, so let's put, I'll put some red on that so it'll stick out. All right, which drone began descending first? Well, this one I don't know, I don't think. Let's look at Ben's. Now, Ben went up to 4.5 and 4.25 and then right down again. So it starts descending after 0.25. I can't see if that's true with Corinne's because I don't have a graph. So I do want to come back over here to my Desmos and put a graph in here so I can see what's going on. So I'm going to X those two out, and then let's take Corinne's. I can't copy hers, unfortunately. I'm going to have to type it in. So -3x squared, c of x equals -3x squared. And then what does it say? Plus 7x plus 1. Plus 7x plus 1. All right, I need to go way back down here because I have zoomed way out. If you'll do zoom fit in here, or square, zoom square, it'll come back to a much smaller window. And you can keep on zooming in. Or you can close your program and just start over. It'll start over with a prettier graph. Okay, that's a good enough graph. So let's take a look at hers. If you click on this point at the top, it's going to show you her vertex, and you can highlight it. And it looks like that's 1.167 seconds. So hers starts to descend when she gets to 1.167 seconds. Ben started to descend at 0.25 seconds. So it looks like Ben's is descending first, or coming down. So Ben's descends first, starting at 0.25 seconds. Corinne starts descending at, let's see, what was that number? 1.167. 1.167 seconds. All right, so I'll color these so they'll stick out. I'll release these keys to you guys later after everybody's had a chance to turn this in so that you can go back and study these before we take any kind of quiz. This will be like your study guide. For C, which of the drones had a greater average increase in height? So you see that word average. This is another average rate of change. So it says from 0 to the time it reaches its maximum height. Well, the maximum height for Ben was this 4.25. So its average rate of change is just the slope between these first 2 points in the table. So the change in y for Ben would be 0.25 4.25. It went from 4 to 4.25, so it just went up. So let me just calculate that right quick. We'll put 0.25 divided by, all right, it went from 0 to 0.25. Well, that's 0.25 also. That's interesting. So both the change in y and the change in x are the same number. So he actually had a rate of change of 1, and that would be feet per second. So that's Ben's. Let me go put him in red. All right, let's try looking at Corinne's. Now she went from 0, 1 to this point. So her y went up 4.083 because it went from 1 to 5.083. So just take off a 1 and you'll have 4.083 for Corinne. So let's write hers down. So 4.183. Let me see if I did that right. 0.083. Not 1. Not bad. All right, and then we'll divide. Let's see what her x's are. She went from 0 to 1.167. Well, that is 1.167. I'm pretty sure that's not going to equal 1. So let's divide those numbers over here in Desmos. And I have to look at them, so I'm going to have to click them again. Oh my, I can't do that because it won't let me. You know what? I'm just going to type this, Control-C, and paste it in here. Wow. Okay, that's not very pretty, but it's about 3.5. So we'll say this is about 3.5 feet per second. So the question is, which of the drone had a greater average increase in height? So Corinne did. So let me fix this. So we'll say Corinne was greater. All right. All right, let's move on to the last part. It says analyze each pair of representations and then answer the questions, justify your reasoning. Which function has a greater average rate of change? Okay, again, average rate of change. So we're still doing slope, but we have to pay attention to this inequality. It says from 2 to 4. 2 is less than or equal to x is less than or equal to 4. So in the table, that's really easy to figure out. In B, the rate of change from the 2 to the 4 would be the change in y from 0 to 4 over the change in x from 2 to 4, and then you divide those two numbers. The other function is not nearly as easy because I have to evaluate f of x at 2 and at 4 to see what that is. So what I'm going to do to make this easier, let's delete this, and let's go back and put f of x in here and see what we get. So f of x was x plus 1 quantity squared plus 20. All right, if I click on the next row, I can evaluate that at 2 and at 4. So we'll say f of 2, and look at that, it just gave me that. So let's do f of 4, and it gave me that. So let's see, I need 29, or no, excuse me, 45 minus 29. Let me do this. I think I can make a fraction in here. Does it give me an option? I don't know. You think I'd be able to find this stuff by now, but I don't know. Yeah, I don't know how to do it. So I'm just going to type a fraction 1/2, and then I'm going to use that to help me to write this. So I need 45 minus 29 on top. And then on the bottom, I need 4 minus 2. And then it tells me that's 10. So it did all that work for me. So I now know the average rate of change from 2 to 4 for f of x. All right, so now let's do the rate of change for b. B is just y equals and doesn't have f of x equals. So we're going to go from 2 to 4. So we'll take the 4 minus the 0 and get, or excuse me, yeah, that's right. The 4 is the second y-coordinate and the 0 is the first. So 4 minus 0 will be 4 divided by 4 minus 2 is 2, and that equals 2. So the rate of change for B, we'll just call it y because it had a y in the table, is 2. All right, so which one had the greater rate of change? Well, clearly f of x is much greater, so we're going to say f of x here is our answer. And I'm going to highlight that in red so it doesn't all run together. We'll put all this in red too. All right, next, which function has a greater minimum? Well, this one's actually kind of cool. I'm just going to graph this. So I'm going to get out of this. Let's X all this out. Get rid of this keyboard, which didn't even help me. All right, let me add a table. And I will actually create the table that they have here for B. I can see the minimum on the graph, so I don't have any work for that one. So let's just graph 0, 4, 1, 0, 4, 0. 0, 4, oops, 0, 4, 1, 0, 4, 0. 1, 0, 4, 0. Is that right? All right, so where is my minimum? Well, I don't know, but I do know it's somewhere in between here. I've got a parabola that's going down, and it's down here, and it's back up. Now, the question is it going to be lower or higher than this minimum? This minimum is at negative 20. It's kind of hard to read that, but it's really far down there, negative 20. Is there any chance that this vertex is all the way down at negative 20? Is it going to be here? Well, no. In order for this parabola to decrease and then come back up, it's going to have to bottom out in this area, somewhere in here. There's no chance it's going to go that far down. So the answer to the question is, which one has the greater minimum? It's actually B. The vertex must be much higher. Well, let's just say the y-coordinate, because that's really all we care about here. The y-coordinate of the vertex of B must be much higher. Whoops, I can't spell today. Than the vertex, than negative 20. Let's just put negative 20. Yeah, it's nowhere near that. So this was, it's kind of a give me. And I will say they would never give us something that simple on state test. So lucky for you guys, we might not be taking a state test. I guess we'll find out soon. All right, let's move on to the next one. I need to make that. Which function's axis of symmetry has a greater x value? Well, this one, now this time the table's the easy one because the y-coordinates here are both 30. So the axis of symmetry would have to be halfway between these two numbers. Now 0, you would think, is the axis of symmetry, but be careful. 0 to negative 3 is only 3 spaces, and 0 to 5 is 5 spaces. So that point 0, 0 is not in the center of those 2 points. Now, you may be smart to put this one in a graph. I don't know. Actually, maybe it is. Let's put it over here, and let's look at these numbers. So, negative 3, 30. Yeah, it would have been easy if they had made the table symmetric, but they didn't. They made these x's not equally spaced. So therefore, you can't really tell what's going on. Now, your y values are way up here. So if you look, your axis of symmetry is going to be halfway between these two y values, which puts it right in here. So, well, what is that? I don't know. Let's take our x minimum and bring it way in. Let's say negative 1, or negative 2 to 3. And we'll count by 5s. Now for our y's, we do have to go to 30. So we'll say negative 5 to 35. Let me count by 5. And then you'll be able to see these points because you got to go to at least 30 to see them. All right. Uh-oh, I've got to go -3 to 5. What am I saying? How about -6 to 6? That'll work. And we'll count by ones. All right, so there they are. So where is our axis of symmetry? So halfway between these two, if we average -3 and 5, add -3 to 5, you'll get 2. Divide by 1, you'll get 1. So your axis of symmetry has to be at 1 because it's got to be right in the middle between those two 30s since they're on the same line. All right, so our axis of symmetry for B is x equals 1. All right, now let's look at A. It's 2x squared plus 4. This is a way smaller graph. I'll just put y equals 2x squared plus 4. All right, the axis of symmetry for this one is 0 because the vertex is right at 0, 4. Make sure I did that right, 2x squared plus 4. Yeah, I did. So the axis of symmetry for A is x equals 0 because the vertex is right it's right on the y-axis. So the x coordinate is 0 and the axis would be 0. So the question is, which one has a greater x value? Well, B has an x value of 1, so B has a greater value. So let's choose that. I'm going to highlight all that in red. All right, so what you're going to do now is do an exit ticket with problems similar to this. And so I've got several strategies we've used here. Let's review them real quick. If you see there's a negative in the front of your equation, either in factored form, standard form, or even vertex form, you know your parabola opens down. So that's important to note. If you see you have a number added to the end, like this 75, you know your y-intercept is 75. So that's something you should know. If you need to graph, you can put it in Desmos to look at the graph or to create a table of values to look at. Rate of change is just slope. So we had to do it several times in this problem or in this assignment. You will have to do slope. Change in y means subtract your y's over change in x, which means subtract your x's, and then you divide the numbers. So I've got your work here. Hopefully that helped you figure that part out. And then finally, you're looking for maximums and minimums. Minimums are the lowest point on the graph. Maximums are the highest point on the graph. Axis of symmetry is a vertical line that goes straight through your vertex. So you will use your x coordinate of your vertex for your axis of symmetry. All right, complete your exit ticket for this assignment, submit, and turn in the assignment. I think you have to click on done or turn in or both. I'm not even sure, but a lot of you are not turning in the assignment even though you finish it and you've got everything done, including the exit ticket. Try to be sure you're doing that because when you don't turn it in, I may not know that you're done and you may not get a grade, and that would be bad. If you have any questions or comments, leave it on your assignment. I will answer you when I check your assignment. You can also go out to the main instructions page and leave questions there, especially if it's a general question that anybody else might want to know the answer to. Put it there and I will answer you, or you can email me. Y'all are doing great work. Keep it up. Until next time, keep working hard and stay safe.